Hi, good evening students. Welcome to online classes on module 2. So today we will discuss the last bit from the module 2, that is Gaussian quadrature for 1D integral or 1 point, 2 point and 3 point methods. Okay, so Gaussian quadrature having a 1D integral, 2D integral and 3D integral. For our syllabus we have a Gaussian quadrature for 1D integral and 2D integral. So in that again we have 1 point method, 2 point method and 3 point methods. So now we'll go with the definition of numerical integral. What is 1D integral or what is numerical integral? We'll go with one by one. A numerical integration can be defined as process of obtaining the approximate value of I. A numerical integration can be defined as a process of obtaining the approximate value of I, that is integration of x1 to x2 f of x into dx, without actual integrating the function, but using the value of f of x at some point of the x equally spaced over the x1 and x2. So that is, numerical integration can be defined as a process of obtaining the approximate value of I, that is that particular integral, that is integration of x1 to x2, that is upper limit to lower limit, a function of f of x into dx, without actual integrating the function but using the value of f of x at some point of x equally spaced over x1 and x2. Okay, so it's nothing but in integration we know that we can do the integration of any functions. It may be sine function, or it may be polynomial function, it may be cos function, it may be trigonometry function, or any function we can integrate. But the numerical integration, or especially Gaussian quadrature, we are integrating the function of f of x into dx. We are integrating the function of f of x into dx within the limit of x1 to x2, that is without actually integrating the functions. Okay, now we'll discuss the Gaussian quadrature for 1D integral. The Gaussian quadrature for 1D integral is given by I is equal to integration of -1 to +1 f of zeta into d zeta. So what is integration? Means it is a summation of the terms. So I can write the integration, that is f of x, it is in the form of summation of I equal to 1 raised to n, that is w1 f of zeta 1. So I can write this w1 f of zeta 1 as w1 f zeta 1 or is equal to w2 f zeta 2 or is equal to w3 plus f zeta 3 plus so on wn f zeta n. Okay, so I can writing the Gauss quadrature for 1D integral, that is I is equal to integration from -1 to +1 f of zeta into d zeta, where f of zeta w zeta or nothing but I can write w1 into f of zeta 1, w1 f of zeta 1 plus w2 s of zeta 2 plus w3 plus so on wn into f of zeta n, where w1, w2, w3, w3 are the weights. Zeta 1, zeta 2, zeta 3, zeta 4 are the, or zeta n is the Gaussian point, or I can another way you can say that it is a sampling point. Okay, w1, w2, w3, w4 are called as weights, and zeta 1 to zeta n we can say it is a Gauss points, or you can say the sampling point. Again, now first we will discuss the 1 point formula, then we will go with 2 point, then we will go with 3 point formula. Now 1 point formula. So 1 point formula will give the integration of -1 to +1, that is f of zeta into d zeta is equal to w1 f of x into zeta. 1D point means it consists of only one weight, it consists of only one polynomial or 1 degree of freedom. So f of zeta is a polynomial order of 2 minus 1, it is a 1 degree of freedom. So I will assume the polynomial function of a0 plus a1 zeta. So if it is 2 point, then I have to take plus w2 into f of zeta 2. If it is a 3 point, I have to take w3 plus fn into zeta 3. If it is a 4, I can take it w4 f of zeta 4, so on. But for 1D point formula, I will go with the function of polynomial order of first order. So that is f of zeta is equal to a0 plus a1 zeta. Again, integrate this function with respect to the limit from upper limit to lower limit, that is -1 to +1. So f of alpha 1, you can write a0 plus a1, or you can write alpha 0 plus alpha 1. So I'll go with you can go with anyone. You can go with a0 or a1, or you can go with alpha 0 plus alpha 0 or alpha 1. You can go with anyone. So I will go with a0 plus a1 in the classes. So here I am taken the a0 plus a1 into d zeta. So w1 into f of into alpha 0 plus alpha 1 into zeta. Again integration of this, you make the integration of this. So if integration of this, what will get the common? So these are the constant terms, a0, alpha 0, alpha 2, or a0 or a1 are the constant term. You can take outside. So only integration of zeta delta zeta, you will get the what? Only integration of zeta into d zeta you will get. So remaining terms are going to get cancelled, that is alpha 0 minus alpha by 2 plus alpha 0 as it is minus alpha by 2 is equal to w1f into alpha 0 plus alpha 1 into zeta 1. So alpha 0 plus alpha 0 is equal to 2 alpha 0 is equal to w1f, and it is a polynomial of alpha 0 plus alpha 1 into zeta. Comparing the coefficient of both sides, compare the coefficient on both sides, we get w1 is equal to 2, zeta is equal to 0. w1 is equal to 2, zeta is equal to 0, because there is no zeta term, and there is a w term is, that is 2. Now thus 1 point formula is given by integration of -1 to +1, f of zeta into d zeta is equal to w1, f of zeta 1 is equal to 2 into f of 1. Call this equation as 1. So this is the formula how to remember. Similarly, we can go with the 2-point formula. Again, the 2-point formula is already told. If it is a 2-point, take the order of second order degree. That is integration of -1 to +1, f of zeta into zeta. So w1 f of zeta 1 plus w2 f of zeta 2, where w1 f of zeta 1 what? a0 plus a1 zeta plus w2 f of zeta is a2 zeta square plus a3 zeta cube. So this is very important for 1-point and as well as 2-point formula. For especially for 2-point formula, a0 plus a1 zeta plus a2 square zeta plus a cube zeta cube, it is of second order polynomial, where w1 is equal to w2 is equal to 1, zeta is equal to plus 1 by square root of 3, zeta 2 is equal to minus 1 by square root of 3. So these are the value you have to remember, because in examination we need to put the values. Everything depends upon this value. Okay, w1 w2 is equal to 1, zeta is equal to plus 1 by square root of 3, zeta 2 is equal to minus 1 divided by square root of 3. Now similarly for the 3-point formula, for 3-point formula also have, again you have to take integration of -1 to +1, f of zeta into d zeta, omega w1 f of zeta 1 plus w2 f of zeta 2 plus w3 f of zeta 3. So again integrate with a limit of -1 to plus 1. So we will get the directly answer, that is w1 is equal to, will get 5 by 9, or you will get 0.5666, or you can go w2 is equal to 8 by 9, or you can write 0.8888, and w3 is equal to 5 by 9, 0.555, or zeta 1 is equal to minus 0.7745, zeta 2 is equal to 0, and zeta 3 is equal to plus 0.7745. These value you have to remember for the 3-point method. Please, these are very important for 1-point, 2-point and 3-point formula. For 1-point formula, w1 is 2, zeta is 0. For 2-point, w1 w2 is equal to 1, zeta is equal to plus or minus square root of 3, zeta 2 is equal to minus 1 by square root of 3. For 3-point method, w1 and w3 is equal to 0.5555, that is you can write 5 by 9 also, or w2 is equal to 8 by 9, zeta 1 is equal to 0.7745, zeta 2 is 0, zeta 3 is 0.7745. Okay, now after this we will go to one problem by solving the one problem by using the 1-point or 2-point formula. Okay, now these questions they may ask for 6 to 8 marks. Okay, any one question is fixed on integration or 1D integral, either it may be 1D It may be 1 point, or it may be 2 point, or 3 point. Usually in 90% cases they may not ask 3-point method, but they may ask. But usually in the last from 4 to 5 question paper they are asking only 1-point method and 2-point method. So now evaluate the integral. Evaluate the integral. Integration of -1 to +1 3 e raised to x plus x square plus 1 by x plus 2 by 1 point and 2 point, and by 1 point, 2 point and 3 point Gaussian method. Okay, simple formula it is: evaluate the integral between limit from -1 to +1 3 e raised to x plus x square plus x plus 2 by 1 point, 2 point and 3 point using Gaussian method. So now I'll go with the 1-point method. So right, that is I, that is integral I is equal to integration of -1 to +1 3 e raised to x plus x square plus 1 by x plus 2. Integrate the above equation. Integrate the equation and apply the upper limit minus lower limit. So -1 to +1 e raised 3 into e raised to x plus integration of x square plus integration of 1 divided x plus 4 integration of 3 raised to ax, that is 3 into e raised to ax. Okay, integration of e raised to 3x is 3 into e raised to ax plus integration of x square is x cube by 3. Integration of 1 divided x plus 2 is log x plus 2. Now apply the limit, upper limit minus lower limit. 3 e raised to x minus 1 plus 3 e raised to minus 1. So e raised to, wherever you have x, put minus 1 and plus 1. 3 into e raised to 1 minus 3 into e raised to minus 1 plus x integration of x square is x cube by 3 minus 1 to plus 1, that is 1 by 3 minus into minus plus 1 by 3 plus log of x plus 2. Again apply the upper limit minus lower limit, means 1 plus 2, 1 plus 3. So log of 1 plus 2, that is 3. Log of 3 to the base e minus log of 1 minus 1 plus 2, that is log of e log 1 to the base e. So after simplification you will get I is equal to 8.1888. So this is the integral of I for the given Gaussian formulae. Okay, now we'll go with the 1-point method. So 1-point method, we know that for 1-point method you have to take the 1D integral. So I is equal to integration of -1 to +1 f of d zeta into d zeta. F of g zeta into g zeta is equal to w1 f of zeta 1. Again we know the value omega w1 as it is. The f of zeta 1 what he given? The f of zeta 1 he given, that is 3 e raised to x plus x square plus 1 divided by x plus 2. So wherever we have the x, so I will go with now zeta. So that e raised to zeta plus zeta square, that is x is there, I can go with zeta square plus 1 by zeta plus 2 is there. So here 1 by x plus 2 is there, so I will go with 0, because we know that w1 equal to 2, w1 equal to 2 and zeta is equal to 0, because 1-point formula it will give w1 equal to 2 and zeta is equal to 0. Now apply the 2 as it is, e raised to 1, e raised to 0, e raised to 0 is 1, so 3 as it is plus e raised to 1, right, 0 raised to square, that is become 0, zeta is 0, zeta square it becomes 0 plus 1 divided by 1 0 plus 2, so that is 1 by 2, 2 into 3 plus 1 by 2, so this is, you will get the 7. So I will get for 1-point method, you will get the answer of 7. Now we will go with the 2-point method. Similarly for 2-point method, you take -1 to +1 f of zeta into zeta, w1 f of zeta 1 plus w2 f of zeta 2. Again we know that, because as already initially I told, for 1-point formula, for 2-point formula and for 3-point method you will get w1 w2 is equal to 3, zeta is equal to -1 by square root of 3, zeta 2 is equal to 1 by square root of 3, that is -1 by root 3 or plus 1 by root 3. So again for 2.2 I have to take, for 2-point method I have to go with the 2 polynomial equation, w1 of f of zeta plus w2 of f of f2 zeta. So f of zeta is 3 e raised to zeta 1 plus zeta, wherever you have the x you just replace the x by zeta. Okay, replace the x by zeta, again integrate. Okay, just keep the values. Again we know the omega 1 is 3, e raised to zeta 1 is -1 by root 3 plus again 1 by root 3 plus zeta 1 is minus 1 by root 3 plus 2 as it is. Similarly here, just put these two value in the above equation, or in this equation you will get I equal to 8.73. Similarly for 3-point method, 3-point formula also you will get the same answer,